This is a short introduction to the Kirchhoff circuit rules lab exercise. So in the previous lab, the Ohm's law lab, you analyzed a couple of circuits, including this one, where there were 4 different resistors in the circuit, and knowing the voltage of the voltage source and the resistance of the 4 resistors, you were able to figure out the currents through each of the resistors and the potential drops across each of the resistors. What about this circuit? So there's 2 voltage sources in here called VA and VB, and 3 resistors, R1, R2, R3, all of which those values are all known. Can you analyze this circuit? Can you find the currents through each of the 3 resistors, call them I1, I2, and I3, and the potential drops across each of the resistors, call them V1, V2, and V3? So it turns out you can't do this knowing just Ohm's law. You can try to use Ohm's law, but it looks like R1 and R2 are in series with each other, right? But there's R3 that's also connected to them, and then there's 2 voltage sources, and you simply can't do it with only Ohm's law. You have to have 2 extra little rules called Kirchhoff circuit rules. And simply stated, they are the sum of the currents into a junction is 0, and the sum of the voltages around a loop is 0. What does that mean? Basically, the first one means any current that goes into a junction like this one here, the same amount of current has to go out, because charge cannot build up at a point. The electrons can't build up any place. Any electrons coming into a junction have to also leave it. So that's the current law. And then the voltages, or the voltages around a closed loop, are 0. So VA, the voltage is higher above VA than it is below VA, and then there's a voltage drop across resistor 1, another voltage drop across resistor 2. The sum of the 2 drops has to equal to the VA rise, right? In other words, the total voltage rise around a loop has to be 0. So using these, here's the first one. I3 plus I1 has to be equal to I2, because the currents going into this junction have to be equal to the currents going out, right? So that's the current rule. And then the voltage rule, VA, has to be equal to V1 plus V2. The 2 drops across the resistors 1 and 2 have to be equal to the rise of VA, and also VB has to be equal to V3 plus V2. The voltage drops across resistor 3 and resistor 2 have to be equal to VB. So here's these 3 things we know, and we can actually figure out I1, I2, I3, and V1, V2, V3 if we know VA, VB, and the 3 resistances. Now here we have 3 equations, and there's 6 unknowns, the 3 currents and the 3 voltages. But there are actually not 6 unknowns, there are only 3, because for each of the resistors, the voltages are related to the currents. Here's Ohm's law for resistor 2, right? V2 is equal to I2 times R2, which means I2 is equal to V2 over R2, and I can replace that in this equation. Likewise, I can replace the other 2 with V1 over R1 and V3 over R3. So now I've got these 3 equations in terms of just the 3 unknown voltages, the voltage drops across the 3 resistors. So I have 3 equations and 3 unknowns. Remember, all the other things are known. The 3 resistances, R1, R2, R3, they're known, and VA and VB are known. So I can use these equations to solve for the 3 V's. And there's a number of ways to do that. Let me solve the second and third equations for V1 and V3. So V1 is just VA minus V2, V3 is just VB minus V2. All I've done is rearranged these 2 equations. Now I have an expression for V1 and V3, which I can put up in the top equation. So here I've just inserted those expressions in the top equation. Now look, this first equation, there's only one unknown, V2, and I can solve for V2. So here's the equation solved for V2. So you see, knowing VA, VB, and the 3 resistances, I can find V2, right? And then knowing the second 2 equations is I can find V1 and V3 from V2. And then, of course, using Ohm's law, I can find the 3 currents, because Ohm's law holds independently for each of the resistances together. So in this circuit, this is how you're going to solve this circuit. You're going to use these three equations and these three equations to do that. So you might want to pause the video and write these things down. This is how you're going to do the analysis. So this is an example of how Kirchhoff circuit rules can be used to solve even very complicated circuits. This is not that complicated a circuit, but even circuits with thousands of components in them can be solved in this way. And even circuits that that operate on alternating current instead of direct current like this. So this is just a simple example. Hopefully this will get you started.